So today we're going to learn a little bit about the Pythagorean theorem. We'll start out with, so here we have a warm-up problem. And so I would like y'all to read through this and see if y'all can figure it out on your own. It says today you're going to classify the following triangles A through E using the word bank below. And so you're given that there's a right triangle, an obtuse triangle, a scalene triangle, an equilateral triangle, and an acute triangle. So y'all work on that for a few minutes and see if you can come up with the answer. Do one of y'all want to come up to the board and try and do it?
Sure, I will. I think this is an acute triangle. Can I use a magic eraser?
Sure.
Hey, look, I got it right.
Good job, Bernie. Would anyone else like to try the next one?
I think this is a right triangle. Can I get it erased too?
There you go. The magic eraser works wonders. All right. Heather, would you like to go next?
I sure will. I think this is an obtuse triangle.
Yeah.
Good job. You're correct. Who would like to try the next one?
I do.
Okay, go ahead.
This is an equilateral triangle.
Good, good.
And I think the last one's a scalene triangle. Or isosceles
Yay.
triangle.
That's awesome.
Same.
There you go. All right, now that we've gone through the warm-up and looked at the things that you know, we'll go on to the next slide. And here we have our objectives for the day. Y'all will be able to formulate an expression using the Pythagorean theorem, and you'll be able to apply this expression to solve real-world problems. At the end of the lesson, we will have example problems, and you will be able to apply the Pythagorean theorem to solve these problems. So let's take a look at a first problem. What is a right triangle? Does anyone know anything about a right triangle?
It has 90 degrees.
It has 90 degrees.
90-degree angle.
Very good.
Yes.
Anyone know anything else?
It has 2 legs.
Yes, it does. And there's one more thing, that property. Yes, Bernie?
It has a hypotenuse.
Very good. So then when we look over here, can use this magic eraser and erase, and we can see. Maybe once we erase it off. You can see that we have ourselves a right triangle with 2 legs, A and B, and then our hypotenuse is C, as we can see there. So next, let's look and see what is the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared, where a and b represent the lengths of the legs of the right triangle, and c is the length of the hypotenuse. So here we have a and b, which are our legs, and then c, which is the hypotenuse. And so you have this equation a squared plus b squared equals c squared in order to solve for one of your missing legs or the hypotenuse if you need it. So next we will look at the proof of the Pythagorean theorem. Where did this formula come from? I have a video on the proof, and it'll explain it a little better using starburst, what we are used to.
Hi, my name is Emma, and I'm here to prove the Pythagorean theorem with starburst. This is my right triangle, and this is my hypotenuse. A squared plus b squared equals c squared. A is 3. 3 squared equals 9. B is 4. 4 squared equals 16. C is 5. 5 squared equals 25. 9 plus 16 equals 25. So I'm going to show you by taking these, starburst, and putting them on top of C, so that you can see that they actually fit, that they actually equal. See, the match is perfect. That is how you prove the Pythagorean theorem.
So now that you've seen that video and you know that it really is true that a squared plus b squared equals c squared, we can move on and try our first example. The first example is for finding the hypotenuse. If a equals 3 and b equals 4, use the Pythagorean theorem equation to solve for the length of side c, the hypotenuse. So we know that a is equal to 3 and b is equal to 4. And we have the equation a squared plus b squared equals c squared. So does anyone know what we would do now?
Plug in the numbers. So square 3 and square 4.
Here we have it again, and so would you like to come up to the board and work the problem?
Sure. So it was 3 squared plus 4 squared equals c squared. So 9 plus 16 equals c squared. So 25 equals c squared. So to find c, we take the square root of both, and c equals 5.
Good job. Okay, now we'll move on to our next example. Let's check to see if it's right. Here we have our solution. A is equal to 3, b is equal to 4. And we have, just like you did, the squared 3 and squared 4. And when you add them up, you got 25 was equal to c squared. And so c is equal to 5. So we know that our hypotenuse here is equal to 5 when b and a are equal to 4 and 3. Now we will move on to our next example. It says, find the missing leg. Now that we know how to use the Pythagorean theorem to solve for the hypotenuse, the next problem is a little more difficult. If the length of side C is 5 centimeters and side A equals 3 centimeters, solve for side B using the Pythagorean theorem equation. So here we have the same triangle, and we know that
C was 5.
C is equal to 5 and A is equal to 3. So now we want to solve for B. Is there anyone that would like to try solving for B?
I'll solve for it.
Okay, Heather, go ahead.
Okay, so since C equals 5 and A equals 3, we'll do
Just touch on the board again.
A squared plus B squared equals C squared. So 3 squared plus B squared equals 5 squared. So that means 9 plus B squared equals 25. Then we subtract 9 from 25, so that will make B squared equals 16. Then we take the square root of both sides, so then we know that the answer is B equals 4.
Good job, Heather. Let's see if you are correct. Here we have our solution. We had A squared plus B squared equals C squared as our equation. And we know that A is 3 and C is 5. So we can plug those two into our equation. And then we look and we see that we're trying to solve for B. So we should subtract 9 from both sides. And that leaves B squared here to equal 16. And to solve for just B, we would take the square root. And we know that B is equal to 4. And so our other leg is equal to 4 when we know the hypotenuse and the other leg. So you can use this equation not only to just find the hypotenuse, but you can also use it to solve for either leg whenever you're missing one or the other. Now we have some special triangles. These triangles include a 3, 4, 5, a 5, 12, 13, an 8, 15, 17, a 7, 24, 25, and a 9, 40, and 41. So we know if you're given a triangle with a 90-degree angle and the sides that are 3 and 4, we know that because of this special triangle rule, that this one will be 5. So now let's try a practice problem. Would anyone like to try to solve this one on their own?
I'll do it.
Okay.
A squared plus B squared equals C squared. So 12 squared plus 16 squared equals C squared. 12 squared is
144.
and 16 squared is, oh, we'll multiply it out. 16, 16, 36. So 256 equals C squared. These two added is 400 and equals C squared. So we take the square root and that equals 20. So C equals 20.
Very good. Thank you, Sarah. Let's look at our second practice problem. Would anyone like to try that one?
I'll do this one.
Okay, Heather, go right ahead.
Okay, so we know that a squared plus b squared equals c squared.
And how do you know that you can use that formula?
Because we see a right angle right here.
Good.
Okay, so we'll have this side be a, this side x is b, and the hypotenuse is c. So a is equal to 9, so 9 squared plus x squared equals 10 squared. So that means that 81 plus x squared equals 100. So then we subtract 81, and we subtract 81 over here, and that equals 19. And so then you have x squared equals 19, and then you take the square root of both sides, and so that means that x equals the square root of 19.
Yes, and you can just leave it as a square root because it's a very long number. So now that you've done this, you've seen a lot of different options for these. So now I'll pass out a worksheet for y'all to do in groups, and we will learn more about the Pythagorean theorem.